Good evening, everyone. In this evening session, we're going to be looking at the triangle. Now, you must know all of your properties when it comes to a triangle. The first thing, you have to be able to name your triangles, right? You have to know that if we have a triangle that has two equal sides and two equal angles, right? So once these two angles are the same and these two sides are the same, we must know that that is an isosceles triangle. They will test us on our knowledge on the names of triangles. If it is that we have all three sides equal, right? So if all three sides are equal, all three angles will also be equal. And that is known as the equilateral triangle. If there are no sides equal, right? So once there's no sides equal, all of the sides are different sizes. We call that a scalene triangle. Sometimes they might ask us for the names of the triangles. If they do, you must be able to name them correctly. So two same sides and two same angles, isosceles. All three sides and all three angles equal, equilateral. Something else to know about the equilateral is that all the angles of a triangle must add up to 180. So obviously, if all of them are equal, we can divide the 180 by 3. And that will simply mean that all of these angles, each of them, will be 60 degrees, right? So this will be 60, 60, 60 in an equilateral triangle. Scalene, no sides equal, no angles equal. They normally use a line like this, like two lines or one line, in order to show which sides are equal. And then finally, there's the right angle triangle. In a right angle triangle, one of the angles is a right angle and a right angle is 90 degrees. Learn your triangles, make sure that you know how to identify them. And next thing you must note is that when we are dealing with finding sides or angles of a triangle, you must know that we are considering either a right angle triangle, so there are two categories, right angle triangle or non-right angle triangle, right? So when you're thinking about the rules, this is the mind map that you're going to follow. If it's a right angle triangle, you have two categories or two forms in which we can work out, and it depends on what they want us to work out. If it's a right angle triangle and there are no angles being considered, we use Pythagoras' theorem. And Pythagoras' theorem simply means that in a right angle triangle, if I have to find a missing side, I'm going to take the hypotenuse, which is always opposite the right angle, and the other two sides, I can label them as L1 and L2. So what I'll do is for each, I'll do an example so that we'll know for sure how it works out. So I'm going to look first at the Pythagoras' theorem. So let's say they gave us a right angle triangle with only sides, right? They might give you two sides and ask you to find a third side. So let's say they gave us a triangle and they told us this side is 10. No, this side, they gave us it as 10. This one is 10. And this side is 7. And they asked you to find the missing side, sorry. So I'm trying to find this side. Now, opposite your right angle triangle, it's always your hypotenuse. The formula for Pythagoras' theorem, you're going to see it in your formula sheet as a squared is equal to b squared plus c squared. But sometimes students, they mix up the a, b, c. So what I prefer to do is, instead of using that, I use hypotenuse squared All right, so what we do is we say the hypotenuse squared is equal to one of the sides squared plus the other side squared. So we label one L1 and one of the sides L2. It doesn't matter which one is L1 and which one is L2. But you must know that the hypotenuse must be labeled accurately. And that's going to be the side that is opposite the right angle, or the longest side of the right angle triangle. So I'm trying to find a hypotenuse. So I could label that as X or any letter that I wish. In the formula, it labeled the hypotenuse A. And then the other two sides, B and C. All right, so L1, I labeled the one with 10, so that's 10 squared plus 7 squared. In this case, we're going to square each one. So 10 squared is 100. 7 squared, that's 49. So we got x squared to be 100 plus 49, which is 149. X is going to be the square root of 149. So we use our calculator. Now you guys use your calculators and work it with me, especially for this topic. So we use the calculator and we use the square root sign. So square root usually looks like this on your calculator. If you don't see it, send it to me or tell me in the chat, and you'll just have to send a picture and I'll find it for you. So we'll end up with x is equal to 12.2, I'm rounding it off to 2 decimal places, So 12.21, whatever is the units. If it's in centimeters or meters or kilometers or whatever it is. Now, remember this part is very important when you find the square root. You have to find the square root in order to find it. All right, so let's take a look at another type. All right, so let's say they gave us these two sides and they asked you to find this third side. Remember, anytime it's a right angle triangle and you're dealing with only sides, you're using Pythagoras' theorem. You write the theorem so that you let them know this is what I'm doing. These are the steps I'm following. So you let them know Pythagoras' theorem. Yes, they know it. Yes, whoever it is correcting it. But it kind of sets the stage that, all right, you had the steps. You know what to do. Maybe sometimes mistakes happen, right? But you could get marks along the way. Let's say you miscalculate something or you wrote the wrong thing down. At least you're able to show, okay, I know the steps. So Pythagoras' theorem is the hypotenuse squared is equal to one of the sides squared plus the other side squared. Hypotenuse, that's going to be 5. So 5 is going to go under the hypotenuse. Remember, the hypotenuse is always opposite the right angle. So it goes under that in the formula. And then it doesn't matter which one is L1 and L2. So I'll have x squared plus 4 squared. Now our goal is to find the unknown x. So remember, we're going to use the equal sign as like a portal. We're going to carry everything except the unknown onto the other side of the equal sign. But once you cross the equal sign, you do the opposite operation. So the opposite of adding is subtracting and vice versa. The opposite of multiplying is dividing and vice versa. If I square something, the opposite is square root. If I have sine, the opposite of sine is sine inverse. Cosine, the opposite of cosine is cos inverse. Tan, opposite of tan, that is tan inverse. So once I cross the equal sign, I perform the opposite operation. So I'm going to start by carrying this 4 squared across. Now that 4 squared was adding. So when I bring it across, it becomes minusing. So it becomes x squared is equal to 5 squared minus 4 squared. Now some people are not accustomed with the x or the unknown on the right-hand side. But remember, if I say x is equal to 6, that's the same as 6 is equal to x. So it doesn't matter which side it's on. So 5 squared, that's 25, minus 4 squared for 4 is at 16. That's the value of x squared. If it's paper 2, you guys can use a calculator. If it's a multiple choice, no calculators, right? So 25 minus 16, that's 9. So x squared is equal to 9. But remember, we want the length, which is x. So I'm going to carry across the square. And the opposite of square will be the square root. So we'll have the square root of 9, which is 3. X is 3. So this will be 3. So basically, if it is that you're given a right angle triangle, no angles involved, but they give you 2 sides and ask you to find one of the missing side, you use the Pythagoras theorem. If, however, it's a right angle triangle and you have an angle, either the value of the angle is given or the angle is asked for you to find, we use trig ratios, which is simply summed up by the phrase the term SOHCAHTOA. So I'm going to explain that now. So remember, angles given, an angle given, or an angle asked to be found, right angle triangle, your go-to is to write SOHCAHTOA on that page. Now, SOHCAHTOA is simply a term used to help remember the 3 ratios of sine. Right, so sine, the so means sine is equal to opposite over hypotenuse. Tan, that's going to be cosine. So that's cos is equal to adjacent over the hypotenuse. Tan, the toa is tan is equal to opposite over adjacent. So basically, SOHCAHTOA is used for us to remember what is the formula to find each of sine, cosine, and tangent. And what you have to recall, it's always sine of the angle, cos of the angle, tan of the angle. That symbol, this means theta, right? And it's just a symbol that represents an unknown angle. So you know how we know pi? Theta is a symbol used in mathematics to represent an unknown angle. So if, let's say they gave us one like this. So let's say they gave us, here the angle is 41. They actually gave us the angle and they gave us one side and asked us to find the other side. Now, it's a right angle triangle, and angle is involved, so we know we're using SOHCAHTOA, right? The SOHCAHTOA. How do we know which of the 3 to use? You have to look at the 2 sides that they are considering. So you're considering this side and this side. So it's either they'll give you 2 of the sides, they'll let you know the value of 2 of the sides and ask you to find an angle, or they might do it like this and give you one side, an angle, and ask you to find second side. In this case, you have to be able to label all of the sides. And it's always with respect to the angle that is given or the angle that you're trying to find. So this is my angle. Opposite to my angle, the line that is opposite or facing my angle, that's opposite. The line that is opposite the right angle is always your hypotenuse. And then the side that is next to is the adjacent. So the two sides that are involved in this question will be the opposite and the adjacent. So you look for which one of the three has both O and A, which is the opposite and the adjacent, and that's going to be tan. So we're going to use that tan of the angle is equal to the opposite over the adjacent. You're going to need your calculator. Make sure you have a calculator and work it with me. If it is that you don't get the answer, it simply means that your calculator might be functioning a little different from what we're like what other calculators might, or how other calculators might function. And it's just a matter of knowing your calculator. So work it with me. In a case like this, the angle is 41. So you'll have tan of 41 is equal to the opposite, which is A, over the adjacent, which is 8. So we're basically going to solve and change the subject to find the value of A. So using our calculators, and you guys are doing it with me, you're going to find tan of 41. When I found tan of 41, you would have gotten 0.869286. I am going to round it off to 3 decimal places. Now, here's the thing about rounding off. When you round off early, it kind of like the answer will vary, right? By a point something, right? So the answer will vary by a point something. What to do is, let's say they ask you to round off to 1 decimal place. You could round off earlier to more than 1 decimal place. And then in your final answer, you round off to 1 decimal place. If they say round off to 2, you go further while you're working it. And then in your final answer, then you round off to the 2 decimal places. So we put in tan of 41 and you got 0.869. All right, so for this case, we are trying to find 8. So I'm going to get rid of the 8. The 8 was dividing. Remember, the symbol in mathematics also means to divide. So it was dividing. So when it goes across, it's going to become multiplied. So we'll get that A is equal to 0.869 multiplied by 8. To do the opposite. Now, you can use your calculator. Right, so you can use it in order to solve it. right? So let's calculate it. Isabel, I'm having some trouble to message back. Yes, you may. Tell me once you're back. All right, so we're using your calculator. And we'll get A as 6.952. And you could round it off to however many decimal places they told us to. All right, so let's say they gave us one to find an unknown angle. Now, when it comes to an unknown angle, 6.9542, yes, that sounds, let me see. Let me just go back. Someone wanted me to double check. Right, very good. It depends on how much you rounded it off to. Right, so it would have depended on how much you rounded it off to. Right, now when it comes to this one, like with angles and so on, with sine, cosine, tangent, there's going to be a little leeway with respect to the decimal, right? Because it all depends on how much you rounded it off to. Right? So somebody might get six points. Let me just see that. I got 6.952. Somebody else got 6.954. But that's because of how much you round off to. All right, so let's take a look at this one now. They are asking us to find the unknown angle. Anytime you have an angle and a right angle triangle, one time you're going to write so, ka, twa. It sets you to know what you're doing. Then you have to identify which one is which. Now the angle could be theta if it's an unknown, or it could be any letter. They could use A, B, C, X, Y, Z, any letter. The angle that is given determines which one is the opposite and the adjacent. So we're looking for this angle. So the side that is opposite, that is going to be your opposite. The side that is opposite your hypotenuse, opposite your right angle, that is your hypotenuse. And then the third side, which is next to, will be your adjacent. So you're going to use the two sides that are being considered or being used. So we have the opposite and the hypotenuse. You look for the ratio that has both opposite and hypotenuse in it. And the one with the opposite and the hypotenuse is that of sine. So you're going to use sine, and it's always of the angle is equal to opposite over hypotenuse. And then you substitute. I'm finding the angle, so my angle is sine theta. The opposite is 18. Hypotenuse is 24. So it's going to be 18 over 24. I'm going to use my calculator. 18 over 24 we got 0.75 as sine theta. But remember, we want to find out what is theta. So I'm going to carry across the sine because I want to get theta alone, or the unknown angle, on one side. So when I carry across the sine, the opposite of sine is sine inverse. Now, some people's calculator, they function differently. So you have to know how your calculator functions. So I'll explain the popular way that works for most calculators. But if you don't get the same answer as I do, you're going to have to send me a picture and let me know, and I'll help you find it. Right? So when I found sine inverse, some person's calculators, you'll see second F, some see second function, some might see this, some might see shift. What you have to do is you're going to press that button and then press sine. If it's cos inverse, you press cos. If it's tan inverse, you press tan. But because it's sine, we press it. We're pressing second function or shift. And once you do that, you put in the value of the side, well, of the angle. And I got sine inverse of 0.75 as 48.59, so on. Right, so 5903, you round it up to how much they say. If you don't, you could just put, you could round it up to however many and put correct two decimal places, or however many you rounded it up to. Now, I found my angle. Angles, the units of angles are degrees. So you put your degree sign. All right, so we're back to our mind map. And remember, you have to know this mind map. So we are finished with the right angles. If they give you all sides and ask you to find one missing side, Pythagoras theorem. Once it's a right angle and they give you an angle, you know it's going to be trig ratios or SOHCAHTOA. What if it's not a right angle triangle? What if it's not? So if it's not a right angle triangle, we have to use the sine rule or the cosine rule. They normally give you this on a formula sheet, right? The only thing is, if it's not CXC, you're going to be required to know it because your teacher might not give you a formula sheet for end of term. But if it's CXC, it is on a formula sheet. So let me just pause and show you guys where it can be found. All right, so normally on the CXC paper, they will normally give you a list of some formulae. Not many, right? But it's good to know what is given, what is not given, right? They do give you the SOHCAHTOA, right? But SOHCAHTOA is easy to remember. And they also give us the sine rule and the cosine rule. Right? So even in the case if we forget it, they do give you it. And I'm going to go over how do we use it. Right? So the sine rule, basically, they are showing the relationship between the side and the angle of each side and angle. Right? So it basically is A over sine of A is equal to B over sine B, which is equal to C over sine of C. Right? So what do we mean by this? If we have a triangle, remember it's a non-right angle triangle, the capital A's, well, for the capital letters, they represent the angles. So let's say this is A, the side opposite the A, that's going to be the corresponding A. So capital A represents the angle, and the side that is opposite to that angle is A. If this angle is B, the side that is opposite to B, we name it small b or common b. And if this here is C, capital C is the angle, this side will be small c. So it's basically this showing the relationship between the sides and the angles of the non-right angle triangle. Now, let's say we were asked to find the sine rule. Now, or asked to use the sine rule. Now, they don't come out and tell you use the sine rule. Now, for this, we use the sine rule when we are given an angle and two sides, or if you're given two angles and a side. For cosine rule, we use cosine rule if you're given all three sides or a side with an angle in between another side. So if you have it like this, if they give you one side, the value of this side, an angle, and another side, they use the cosine rule. But I want to try the sine rule first so that you'll see how we use it. All right, so let's say they gave us a triangle like this one. So they gave us here as 95 degrees. They gave us here as 32 degrees. They gave us P, and here as 21. Now, anytime you realize it's not a right angle triangle, but you're looking for a missing side or a missing angle, you write your sine and your cosine, right? So sine rule and your cosine rule. Now, sine, remember you're using that. Sine is the one with the bad word, right? So because that one starts with A, you have to know that the other condition also starts with A, right? So remember, for sine, it's A angle side side and angle side, right? So it's angle, especially angle side. For cosine rule is if they give you all three sides, or they give you a side, an angle, and a side. Right? So remember, cosine has the S's, sine has the A's. Now, they gave us two angles and a side. Which one has two angles and a side? The sine rule. So you identify what was given to you. They gave us two angles and a side, so we know we have to use the sine rule. So you write your sine rule, which basically is the side over the sine of the angle is equal to another side over side of the another angle. Now your question is, Miss, what about the C part? They just use these to show that that is the relationship of all of the sides. So we're actually just using two of them in order to solve. So watch this one. Let's say this angle, I could label this A. It doesn't matter which one is A and which one is B. What you have to know is that if I label this A, the side that is opposite to it will be a common A. And if I label this angle as B, remember the angles are capital, the side that is opposite will be common B. Now we could substitute. A is 21. Sine A, remember A is 95 degrees. So that will be sine of the angle, which is sine of 95. B is P over sine of B. Sine of B will be sine of the angle, which is 32 degrees. So you basically just sub it into it. Right. So you're using your calculator to solve these values, right? So you have 21 over sine of 95. Again, remember, it depends on how much you round off to. You might have a slight variation with your answer by point something, right? So sine of 95, I am rounding off to 2 decimal places, no, 3 decimal places. So we'll have 0.996, and then P over sine of 32, I got 0.529, so I round it off to 53. As remember, again, you might get a slight variation because when I rounded off this one, I got it to be 0.530 for the 3 decimal places. In mathematics, when it comes to algebra, meaning solving unknowns and you have fractions, anytime you have a fraction equal to another fraction, in order to find the unknown, we could cross multiply, right? So cross multiply meaning I'll multiply this times this, 4 2s are 8, and I'll multiply this times this. 8 times A will be 8A. So you cross multiply and then you could always carry across and do the opposite, which would be divided. So I'm going to apply that to this part here. So I'm going to cross multiply. So it becomes P times this. I'm working across here now. So P times that will be 0.996P. And then this times this, right? Remember cross multiplying. And I'll end up with 21 times 0.53. And I got 11.13. In order to find out what is P, I'm going to carry this across. It was multiplying. So when it goes across, you're going to be divided. So you'll have 11.13 divided by 0.996. And we'll end up with I got 11.175. So 3 decimal places. Right? So that would be centimeters, meters, whatever units they gave us. All right, so let's say they gave us this one. Now you know it's a non-right angle triangle. So you know it's either the sine rule or the cosine rule. How do we know which is which? You look at what is given. The values that are given, the actual numbers that are given. So for this one, they gave us an angle and 2 sides. Now, I know you guys are wondering, Miss, this one has an angle and this one also has an angle and 2 sides, but what's the difference? For this one, when they gave us the angle, the side is the angle is in between the sides. If you look at this, I have a side given here and a side given here, but the angle is not in between. If the angle is in between, then we use the cosine rule, right? So it's like a mind map. Make sure you know your mind map and we're able to like follow through the map, the mind map, and know which one to use. So I'm given 2 sides and an angle. The angle is not in between, so you know it's not the cosine rule. So we're using the sine rule. So the sine rule, remember, you're only using 2 of them, right? All 3 of them was used to show the relationship of all the sides to all the angles, right? But we only need 2 in solving. So you label that. So if this angle, I could label this angle as A. The side that is opposite or facing that angle will be corresponding with a small a. I could label this angle B, and I could, the side that is opposite, that's going to be corresponding with small b. So A will be 8 over sine of A is 47. So that will be sine of 47. B is 9 over sine of B. Remember, the big B is the angle. So that's going to be sine of X. Because remember, we're trying to find the angle now. So I can use my calculator, find out what is sine of 47. So sine of 47, remember you're working with me. And I got 0.73135, etc. I just rounded it off to 3 decimal places. Is equal to 9 over sine of X. Remember, we are looking for X. Anytime you have in algebra, a fraction equals another fraction, remember, we are going to cross multiply. So we're going to cross multiply. So you're going to end up with sine of X times 8. So I'll put 8 sine X is equal to 9 times this. So that will be 9 times 0.731. Use your calculators and you'll get 9 times 0.731. That's going to be 6.579 as 8 sine X. I want to find out what is sine X. I'll carry across this 8. It was multiplying. So when it goes across, the opposite is going to become dividing. So we're going to end up with 6.579 divided by 8. And we got that sine X is equal to 0.822. But remember, we want to know what is X. So we're going to carry across the sign. Once you cross the equal sign, you do the opposite. So it becomes sine inverse of 0.822. So sine inverse of 0.822, and we'll get 0.7497. I'll round it up to 2 decimal places. So I got 0.75. No, that's not something wrong there. Right, so you press your sine inverse of 0.822. Right, so check it over. Sine inverse of 0.822, and we got 55.2855. Right, so 55.29. You guys could double check on your side too. All right, so checking in. So my angle X will be this value. All right, so let's take a look at this one. Now, they gave us a side, an angle, and a side where the angle is in between two sides. Remember, with your sine rule, you're using it for either an angle and two sides, or an angle, another angle, and a side. Next, for the cosine rule, you're using the cosine rule if you have all three sides or a side in between with an angle, or a side with the angle in between another side. So because the angle is in between the two sides given, we're going to use the cosine rule, which is a squared is equal to b squared plus c squared minus 2bc cos of a. Now, what you need to know is that letter A, if you notice, you have A is equal to this, and then you have cos of A. So the angle this angle here, we're going to label that A, and the side that is opposite would be the corresponding small a. Right? So this side must correspond with the cos of the angle that is opposite to it. And then the other two, it doesn't matter which one is B and C. The other two sides, it doesn't matter. So A is what I'm trying to find. So I'm going to substitute X for it. B, right? So it doesn't matter which of the other two sides is B or C. So that will be 20 squared plus C, which is 15 squared, minus 2 times B. Remember, we had B as 20. And then C, we had that as 15 cos of A. And A, in this case, 120. So now we're going to use our calculator, remembering BODMAS, and we're going to solve. So I could work all the multiplications and the brackets. So 20 squared, or 20 by 20 is 400, plus 15 squared, or 15 times 15, that's 225, minus, anytime you have brackets with nothing in between, we understand that it means to multiply. So it's going to be 2 times 20 times 15. And that's going to be 600 cos of 120. So this comes like saying 600 times cos of 120. So I have more multiplication to do, so I need to solve that there. So I find out what is cos of 120 first. On my calculator, we press in cos 120, and I got negative 0.5. So we'll end up with negative 600 times negative 120 0.5. So negative by a negative becomes a positive. So that's, so negative 600 times negative 0.5, 600 times 0.5, we got 300, but it became a positive. Because when you multiply and when you have two same signs, the answer is positive. So we'll end up with 400 plus 225 plus 300. I got 925. We have to find the square root because we carry across the square opposite will be square roots of 925. And we got that to be 30.413, etc. So when it comes to our sine rule and our cosine rule, we need to make sure that you know when to use the sine rule and you know when to use the cosine rule. All right, so we have done our mind map and how to decide whether or not we use Pythagoras theorem, trig ratios, which will be the SOHCAHTOA, sine rule, or cosine rule, right? So to know which one you use, you just like go through and you ask yourself, okay, which path am I following? Now, there are several types of questions that come with respect to these rules. They could have angles of elevation. They could have angles of depression. And they could also have bearings. What I'll do today is I'm going to look at the bearings. Now, when we're speaking about bearings, we need to understand what is a bearing. Now, in mathematics, when we speak of bearings, we are looking at an angle of one object or one location from another location or another object. But it's always measured from, the angle is always measured from north, right? So you know north is always upward. It is always measured from north, and it is always measured from north in a clockwise direction. Right? So it's always measured from north in a clockwise direction. Another thing to note is that when you're dealing with bearings, the angles must always have three digits, It must have 3 digits. So like, let's say an angle is, let's say this is 30 degrees. If we're dealing with bearings, it is going to be written as 0, 30 degrees. So the 30 degrees will be written like this because we must always have 3 digits. All right, so let's take a look at a question with respect to bearings. So I'll read the question. In fact, let me put it up on the screen so you can see it. So E, F, G, and H are points on level ground. So E, F, G, and H. In this question, picture that they are on the floor. Those points are on the ground. It says that show that the value of x is up here, is 29.5 correct to 1 decimal place. Now, anytime they ask you to show, it means that they want you to use one of your rules in order to show it. All right, so let's take a look at this one. So I'm going to zoom in so you can see it clearly. Remember, we are dealing with triangle. So we're applying one of the rules that we have done before. Show that the value x is 29.5. Now, x is a part of this triangle here. I'm going to pull out that triangle. Now, they gave us this side, and this side. Now, I'm looking for an unknown. Anytime I am given a triangle that is not a right angle, we know we have to use either sine rule or cosine rule. Sine rule, remember, that will be an angle, side and side given, or an angle and a side given. Cosine rule is if they give you 3 sides or an angle with 2 sides on either side. Now in this case, they gave us the values of 3 sides. So that means I have to use a cosine rule. So you write your cosine rule. A squared is equal to b squared plus c squared minus 2bc cos of A. Now, remember, this side must correspond with the angle. The angle we're talking about is this angle I'm trying to find. So this is A. So the side that is opposite, that's the corresponding small a. And then the other 2 sides will be B and C. It doesn't matter which is B and which is C. Then we substitute. So A is 6.9 is equal to B squared, that's 5.3 squared, plus C squared, that's 11 squared, minus 2 times B is 5.3 times C, which is 11, cos of A. That's what we're trying to find. So the A is actually x. So you could put cos of x. Let's solve. So we'll end up at 6.9 is equal to 5.3 squared. Use your calculators. So 5.3 times 5.3, that will be 28.09 plus 11 squared, or 11 times 11 is 121, minus 2 times 5.3 times 11. I got 116.6 cos of x. Our goal is to find for x. I'm just covering here to make some space, right? Right. So we'll end up with 6.9 is equal to, I could multiply, I could add this, right? So 28.09 plus 121, I got 149.09, right? So 149.09 minus 116.6 cos of x. I could carry this across. It was adding, remember the sign is in front, this negative belongs to what? The 116.6. So because this was adding, when it comes across, it becomes minus. And we got negative 142.19 is equal to negative 116.6 cos of x. Now remember, our goal is to find out what is x. So I'm going to carry this across. But remember, this was attached to the cos x through multiplication. So when it goes across, it's going to do the opposite of multiplication, which is division. So it becomes 100, negative 142.119 divided by negative 116.6, which is equal to cos of x. So 142.19 divided by 116.6, we got cos x. Just a second, let me just double check something. You know what happened here? I didn't square the 6.9. Right, so remember, it's 6.9, it's a squared. So this is supposed to be squared. Right, so it should be 6.9 squared, and 6.9 squared, that is going to be 6.9 by 6.9, that's 47. Right, so here should be 47.61, right, because it was supposed to be 6.9 squared. Remember, it's a squared. So when I bring the 149 across, it becomes 47.61 minus 149.09. Right, so 47.61, take away 149.09, and I got here Right, so when we subtracted it, we ended up getting 101.48. So when I brought this across, it will be 101.48 divided by this. Right? When we carry it across, 101.48 divided by that. Use your calculator. And we got cos of x. When I divided this, we got positive 0.866209, etc. You see how they said to round off to one decimal place? Like here, I could round off to more than one, so that in the final answer, you will round off to the one decimal place. So we know that cos of x is equal to 0.866. When I carry across the cos, the opposite of cos will be cos inverse of 0.866. So you use a calculator, and we got cos inverse of 0.866. And I got 30. So that means I have to leave this as is. So let's come back to here. So when we divide this, don't round it off. All right, so don't round it off, so we'll get their answer. So you have your 101.48 divided by 116.6. And I got 0. Remember, I'm not rounding it off. All right, so we'll end up with 0.87032599005. So cos of x will be equal to that. So when I carry across the cos inverse, it becomes cos inverse of this. And then cos inverse of that value on your calculator, I'll get 0.87503259005. And I got the 29.5. Right? So basically in questions like these, where they say to show, is basically they give you the answer, but you have to show the working to get it. All right, so I'm going to pause here for this one.